Hello everyone, welcome to my chemistry channel B.L.DASH, short and sweet in chemistry. Now I am going to explain the short revision of reaction in organic compounds, and that especially the reaction involved in the preparation of alkene. And already in part 1 in part 1 I have explained the reaction involved in the preparation of alkene. Now so many reactions are there in the preparation of alkene, and this is the from alkyl halide. From alkyl halide, how can you say alkyl halide chapter, that is in 12th class. But anyhow, we should know here how can you prepare alkene from alkyl halide. See here, alkyl halide when alcoholic. What is alcoholic? Ethyl alcohol, ethanol. When alkyl halide react with alcoholic potash. Potash means KOH. You will take KOH and C2H5OH. Then you will get dehydrogenation. The reaction is known as dehydrohalogenation, means hydrogen and halogen both will form as a byproduct, and the main product, that is alkene, and that is also called beta elimination. Now you can see this here, ethyl halide C2H5X. Here what you will take alcoholic KOH and heat it. What happens here, from this beta carbon, this is called alpha carbon, this is called beta carbon. From beta carbon hydrogen, from alpha carbon halogen, both will react and gives as a byproduct. Here it gives as a HX. So here what is the main product? Alkene. What is that? Ethyl halide gives ethene and byproduct as HX. Again see, since it is, why it is called beta elimination? Because here from beta carbon you will take one hydrogen, from alpha carbon you will take one X halogen. It gives as a byproduct HX, and alkene is the main product, and that is why it is called beta elimination reaction. And here D mean removed, hydrohalogenation mean H and X. HX, hydrogen also removed, halogen also removed. That means here you can see HX removed. Now rate of reaction depends on the alkyl group. How can you say what is the rate of reaction, whether it is speed or not or slow? Then you can say it depends on alkyl group. What type of alkyl groups are there? And halogen atom, what type of halogen atoms are there? It is observed iodine greater than bromine greater than chlorine. That means if iodine present, then the reaction more faster, and here greater than bromine greater than chlorine. Similarly, depends on alkyl group. You know, three types of alkyl groups are there: primary, secondary and tertiary. Here tertiary alkyl group is more faster than secondary, than primary, or you can say tertiary alkyl, that means it is rate is more faster than secondary and primary. So here you can see one example. If you will take simply primary, that group is there as a primary, and here primary halide is there, and you will take alcoholic KOH. You will take alcoholic KOH and heat it. When you will heat, it will get alkene. R is one alkyl group, so it is simply primary alkyl halide. So you will get primary alkyl halide will give then one alkene plus HX. Again you listen, rate of reaction depends on alkyl group and halogen group. Halogen group, you know, bromine, iodine, chlorine are there, important. And now iodine, if iodine is there, there is more rate of reaction is very fast than bromine than chlorine. Similarly, depends on alkyl group. Alkyl groups are primary, secondary and tertiary. If tertiary group is there, that is more faster than secondary than primary. That is why here also you can take example of primary halo alkane. It will give that alkene plus HX. and here this alcoholic KOH and you will heat it. Now you will see if secondary alkyl group is there and tertiary alkyl group there, and what happened towards the reaction, and we will proceed one by one. You can observe here different examples. The example that is ethyl chloride, that is chloroethane. IPC name what? Chloroethane. Chloroethane when react with alcoholic potash or alcoholic KOH, what is the result? First HCl is the byproduct, and after that it react with KOH, so the main byproduct is KCl, potassium chloride, instead of hydrogen chloride. Actually hydrogen chloride is formed, but here what happens? Here HCl react with KOH and gives KCl and water. Similarly, it is 1, 2, 3 propyl bromide, or you can say bromopropane, having 3 carbon atoms, react with alcoholic KOH. Here also you will get KBr water. Why is it byproduct KBr and water? Because first it produces HBr, hydrogen bromide, and after that react with KOH, it gives KBr plus water. And what is the main product? Propene. 1, 2, 3. After 1 there is a double bond propene. Then come to 2-bromopropane, or in common name it is called isopropyl bromide. 2-bromopropane. KOH alcoholic. Alcoholic KOH when react, same Br and H, it gives HBr is the byproduct, and HBr react with KOH, it gives KBr and water. See here CH3, CH, CH2. From this here one hydrogen comes to bromine and gives as the byproduct HBr. Again see CH3, CHBr. From this one hydrogen react with bromine and gives HBr. Later it changes to KBr. And what is the main product? CH3, CH, CH2. That means 1 propene. Same result as this one. Now here 2-bromobutane. 2-bromobutane, what is mean? Here in 2 position there is a bromine, and when it react with alcoholic KOH, then what happens here? It gives 2 type of products. Why it is 2 type of products? Because there is a chance bromine react with this hydrogen, 1 product, bromine react with this hydrogen, 1 product. So there should be 2 products. Then which one is the more, which is the less product? Now the question is, here the scientist Sergeyev produced one rule, that is called Sergeyev rule. According to Sergeyev rule, it said that if hydrogen halide is eliminated, because in this case you see elimination reaction particular here, hydrogen halide is formed as byproduct. After that react with KOH, gives KBr and water. So if hydrogen halide is eliminated by 2 ways, I told, if this react with this is 1 product. If Br react with this hydrogen, there are another product. So it gives by 2 ways. If hydrogen halide is eliminated, then what type of alkene form more? Because there are 2 types of alkene form, then which one is more produced? Here alkene form in excess, which one? In which carbon atoms joined by double bond having more alkylated. Joined with double bond means this one, this carbon and this carbon. The 2 carbons here, that will join what type of alkyl group? What type of alkyl group join to this carbon and this carbon? Because the rule said that alkene is formed in excess where the carbon atom joined by double bond having more alkylated. More alkylated means that is major product. Now you can see here this is 1 product and this is 1 product. Now you can observe this name is but2ene. and name is but1ene. Now question is, which is the major product and which is the minor product? Now here one alkyl group CH3, this side one alkyl group CH3, there are two alkyl groups. In this case but1ene, in this case before double bond, that means this double bond joined by two carbon, here no alkyl group, here only one alkyl group, that is ethyl. That means you can say this is the minor product. Sorry. Next is 1, 2, 3, 4. 1, 2, 3, 4, and here bromine is near to this one. 1, 2, 3, 4. 2 bromo, 3 methyl, and 4 carbon is the longest chain butene. Again see, 2 bromo, 3 methyl, and long chain butene. 2 bromo, 3 methyl butene. When react to the alcoholic KOH, there are two ways that HBr is produced as a byproduct, because in this side, if you say this side HBr, this side there is a double bond, and again the next product, if this Br react to this hydrogen, this is the product. Again observe, bromine in the middle here, and bromine can react to this hydrogen, bromine can react to this hydrogen. That means there are two type of products formed. One is 2-methyl but2ene, 3-methyl but1ene. How can you name it? 1, 2. After 1, 2, 2 methyl. After 2 there is a double bond but2ene. Here 1, 2, 3 methyl and but1ene, and it is minor, and this one is major. Then question is why? Because I told, according to Sergev rule, and the carbon atom joined by double bond, and you will see how many alkyl groups are there. This side 1, this side 1, 2, totally how many? 3 alkyl groups in this case. And here before and after double bond, these two carbon, you will check what is the number of alkyl group is there. In this side there is no alkyl groups, but this side there is a isopropyl group, only one. You count the number, not the count the what are the number of carbon atoms. You will count the number of alkyl groups. In this first case 2-methyl but2ene. In this case there are totally 3 methyl groups. But in second case, which is minor, that is 3-methyl but1ene, here only this side there is no alkyl group, and this side only one alkyl, that is isopropyl, that is means one alkyl group, monoalkylated, and here 3 alkylated, that means 3 alkyl group trialkylated. In this case monoalkylated. Now you can say which one was the major and which one is the minor. This is the major product, this is the minor product. It is only possible by following our Sergev rule. Again, what is Sergev rule? See, if hydrogen halide eliminated in different ways, then you will check which one alkene is more, which is major product. That means here you will observe the carbon atoms joined by double bond, and which one is the more alkylated. Before and after double bond, you will check what is the number of alkyl group, and you count the number of alkyl groups. That is the major product, which one is the more alkyl groups. Again this one, here you can observe, here only 2 alkyl groups, here only 1 alkyl groups, that is why it is the major one. Similarly, here also you can find there are 3 alkyl groups in first case, and there are 2 alkyl, only 1 isopropyl group, 1 alkyl group, that is why it is the minor product. I hope you can understand the reaction of haloalkane with aqueous alcoholic KOH. Remember, if you will treat aqueous KOH, the product is totally different. It will produce alcohol. But here, since we are seeing here what is the preparation method, what are the reactions involved in the preparation of haloalkane, that is why you will take preparation of alkene. Preparation of alkene from haloalkane. This is one type of beta elimination reaction. This is also called dehydrohalogenation reaction. According to the dehydrohalogenation reaction, you will see what are the main products, how many alkenes are produced. So this is very, very important. And here we will see, we have seen here how you are treating alcoholic KOH and how this haloalkane gives alkene. And I hope this is clear to you, and hope you will subscribe my channel B.L.DASH Short and Sweet in Chemistry, and hope you will subscribe and also like and share my channel. And thanks for watching my video. Thanks again to all. In coming video, again we will see the different reactions involved in the preparation of alkene.